This is sections 5.1 and 5.2, classifying triangles and finding angle measures. So let's first start with classifying triangles. There are 4 ways to classify triangle by angle. So if it has 3 acute angles, that is considered an acute triangle. If it has one acute angle, the other 2 angles are acute, but we have one acute angle that automatically makes it an acute triangle. If we have a single right angle, and the other 2 angles are acute, it's considered a right triangle. And if all 3 angles are congruent, while they are acute, they're specifically congruent to each other, we would call that equiangular. Equal angles, equiangular. Then there are 3 ways to classify a triangle by side. If it has 3 sides that are all the same, that is called equilateral, right? Lateral actually is like sides, so equilateral. If it has 2 congruent sides, it's an isosceles triangle. And if none of the sides are the same, it's considered scalene. So let's look at these 3 figures and let's classify them by both their sides and their angles. So in this first picture, I see it has 2 sides that are the same. So 2 sides being the same makes it isosceles. And I see it has a right angle, so it makes it a right triangle. The second one, I don't have any sides marked the same, so I cannot assume any of them are. So we're going to call this scalene. And I do have an obtuse angle here, making it an obtuse triangle. Our last one, all 3 sides are 7 centimeters. So all 3 sides are congruent. That's we call that lateral. And all 3 angles are 60. They're congruent to each other. That's equiangular. So when the sides of a polygon are extended, other angles are formed. So normally, the original angles in the picture are called their interior angles. But if I extend the sides and now make additional angles, those are outside the figure. They're called exterior angles. And we're going to learn things about the measures of the interior angles, but also things about the measures of the exterior angles. Note that every interior angle and every exterior angle do form a linear pair. So the first thing we'll talk about the interior angles. The sum of measures the angles of a triangle is 180 degrees. So the measure angle A plus the measure angle B plus the measure angle C equals 180 degrees. Right? So all triangles add 180. So let's use that. I have 1, 2, 3 angles. All 3 together should add up to 180. So that's 5x minus 2 plus 3x plus 4 plus this angle here is a right angle, so 90 equals 180. If you wanted, we could have just had the 5x minus 2 plus the 3x plus 4 equals 90. But if you're more comfortable setting all 3 together to 180, that's fine. So here we have 8x plus 2 equals 90. 8x equals 88. If we subtract 2, divide by 8, x is 11. And now we want to find each angle measure. We already know that one's 90. So I'm going to put 11 in here. So we have 5 times 11 minus 2. 55 minus 2 is 53. And then we have 3 times 11 plus 4. 33 plus 4 is 37. So my angles are 53 degrees and 37 degrees. So now we're going to talk about exterior angles. So exterior angles, like we said before, are the ones that are formed when you extend the side. And it says an exterior angle is always equal to sum means plus, of the 2 non-adjacent interior angles. So this angle would be adjacent to angle 1. The other 2 angles, 2 and 3, are the non-adjacent angles. So the measure of angle 1 actually equals the measure of angle 2 plus the measure of angle 3. So here we want to find the measure of angle 1, but I have an exterior angle 10, and I've non-adjacent interior angles. So we're going to say the exterior angle equals sum of the two non-adjacent interiors, 3x plus 40. So we could subtract 3x. I could add 10, divide by 2, x is 25, which means I can either put 25 here, and then I know that 3 times 25 is 25 degrees, or I can put 25 here, 125 minus 10 is 115 degrees. So I know these two are a linear pair, or these three adds 180. It's going to be the same thing either way. So it's easier probably to do these two are a linear pair. Come on. So we could say that the measure of angle 1 plus the 115 equals 180. Subtract 115, the measure of angle 1 is 65 degrees. So go ahead and try these next two. Find the measure of each acute angle in the first picture and use the exterior angle theorem to find x first and then plug it back in to find the measure of angle JKM. Pause, and once you're ready to see the answers, hit play. All right, so for number 1, if I add up all three angles to 180, I get 32. And if I substitute 30 back in, it's 64 degrees, and 30 minus 6 is 26 degrees. For the second one, I take my exterior angle, so it's 25, and set it equal to x plus 70. So when we solve for x, we get x is 75. Plugging it back in, 2 times 25 is 150, and 150 minus 5 is 145. Now we have some more complicated pictures. So we're going to have to work with different triangles within the picture to find different measures. So I can find angle 1 right now because I have a triangle right here. All right, that's a triangle. No. So the measure of angle 1 plus 72 plus 57 is going to add 180. So when I do that, I actually get 51 degrees for the measure of angle 1. And I'm going to plug 51 in there. I know that down here, I have a right angle. So 72 and 2 together should add to 90, right? Because I see that right angle right there. So if I do 90 minus 72, I would get the measure of angle 2 is 18 degrees. For angle 3, I would actually use a linear pair. Angle 3 and 57 form a linear pair. So I could do 180 minus 57, and I get 123 degrees for the measure of angle 3. And now I have actually a few options for how I wanted to find angle 4. I could use the big triangle on the outside because it had an angle of 90 in this corner, an angle of 51 here, an angle 4. I also could have used the smaller triangle down here at 18, 123, and 4 adds 180. Or I knew that 57, this exterior angle, equals the sum of 18 and 4. So no matter which way I do it, I get 4 is 39 degrees. When I'm looking at problem B, we have a right angle here, which means on the other side, because it's vertical, is another right angle. So within this triangle down here, I know I have 90 plus 33 plus angle 2. So I could do 90 plus 33 is 123. Take that away from 180. The measure of angle 2 is 57 degrees. And then at the top, I have the same thing. I have 90, 53, and angle 1. So I'm going to treat all three of those as 180. So 90 plus 53 is 143. 180 minus 143 gives me a measure of angle 1 as 37 degrees. All right, and the next one, they're telling me I have triangle PQR, giving me a measure for angle P, a measure for angle Q, and a measure for angle R. I can solve for x is 1, 6, 8, 8x. Negative 12, negative 12 is 39, plus 3 is negative 36. So when I add 36, 8x is 16, divide by 8, x is 27. So that's my x value. Now I want to find the measure of each angle. I have to plug that x is 27 back in. So for P, that's 27 minus 12. So the measured angle P is 15 degrees. For Q, that's 5 times 27 minus 27, which comes out to be 108 degrees. And then for our last one, for angle R, that's 2 times 27 plus 3, that's 57 degrees. So that's actually the end of section 5.1, and now we're going to talk about section 5.2, which is congruent figures. So congruent triangles have the same shape and size. And this means that all of their corresponding parts, like all the corresponding sides and all the corresponding angles, are congruent. So when triangles are congruent, we can actually write something called a congruency statement or a congruence statement. And it says here, a valid congruent statement must match all corresponding angles and sides. So you notice we have triangle ABC. A had 1 mark, and it matched with D that had 1 mark. So in our congruent statement, A and D are in the same place. B had 2 marks, E has 2 marks, B and E are in the same place. C has 3 and F has 3, C and F have 3. And it also is going to work for the segments. Segment AB, the first 2 letters, should match segment DE. Segment AB had 1, segment DE had 1. So every corresponding part matches in our figure. So what we can do is we can write a congruent statement if I have everything marked. The first one, whatever I want to call the first triangle, I'm going to call this thing a half. It doesn't matter what I call the first one. That's just how I match it in the second. I started with A, that's 2 marks. In the second triangle, I have to start with T, that has 2 marks. Then I went to K. K has 3 marks. So that matches with F with 3 marks. And then L was last with 1 mark, matches with R last with 1 mark. All right. It's also asking us to identify all pairs of congruent corresponding parts. So now we're going to identify all the congruent angles. Two kinds of angles. Angle J is congruent to angle T. We have angle K is congruent to angle S. We have angle L congruent to angle R. So those are all the congruent corresponding angles. And then for the congruent corresponding sides, I can actually use my congruent statement, or I can look at my picture. JK is congruent to TS. KL is congruent to SR. All right, so we had KL congruent to SR. And then JL, first and last here, congruent to TR, first and last here. So go ahead, you're going to practice, try this last one. Write a congruent statement and identify all pairs of congruent corresponding parts. Pause, and when you're ready to see the answer, hit play. Alrighty, let's check our answers here. This is not the only way you could have written this first congruent statement. As long as your T is in the same place as G, your P in the same place as H, and your W in the same place as D, you're okay. So you could have had something like PWT is congruent to HDG or something like that, right? So it's okay if it does not look exactly like this. Right, then our congruent angles. So T was congruent to G, P was congruent to H, and W was congruent to D. And segment TB with segment GH, segment PW with segment HD, and segment TW with segment GD. And that is the end of 5.1 and 5.2.